Hello, today we will learn how to multiply a matrix by a scalar. So a scalar is just a number. So keep in mind that it's not a matrix. So if you want to multiply a matrix by a scalar, it's very easy. What you do is just multiply every entry of the matrix by that scalar. So for example, if we were to have a scalar K, so times the matrix A, what we would do is just, let's say that this is our matrix A. Okay, so if this was our matrix A, as you can see here, I just put an arbitrary, like just any size, I or J. The ellipses right here means that there are some rows and columns in between that I didn't write because there wasn't really like enough space or whatever. And so just keep in mind that you might see some matrices written like this, and it just means that you don't know what size they are, just that it's IJ. Remember, number of rows times number of columns. Very well. Now, so putting that aside, if we want to multiply this matrix by K, by that scalar, so KA, we just have to multiply each entry by K. So it will look something like this. And as you might observe, the size doesn't change. The size of the matrix. So what we just do is multiply each of the entries by K. You might not have noticed this, but in the previous video, in adding and subtracting matrices, I actually showed you how to multiply by -1 in order to subtract. So I told you that when you got -b, what you did is just putting all the entries as negative numbers. I'm sorry, as their negatives, not necessarily negative numbers, as the negatives of their entries. And so actually this is just multiplying -1 times b. So the scalar in this case is -1. Let's just put b right here since I already did it, the example with b. Okay, and so that is basically it. You are multiplying every entry by the scalar, by -1 in this case. But now, what would happen if you want to multiply a matrix by 0? Well, very easy. The only change is that all the entries become 0, because as you might recall, any number times 0 is equal to 0. And so we just give the same size, same everything, but now all our entries are 0, which is just what would have happened if you multiply a number by 0. There's nothing out of the ordinary just because it's a 0. Also, now that we know this, I want to show you that if you added the negative of a matrix to the matrix itself, you would get 0. Well, actually like 0a, because you still keep the same size, as you might recall. So why does this happen? So if we were to have a matrix, I'm just gonna do it 2 by 2. You must know that it doesn't have to be a square. It can be a rectangle, and it can have infinite many entries. So, but just to make it a little bit easier, I'm gonna do it 2 by 2. And so if we were to add these two matrices, like so, you would actually get every entry with a 0. So here we want, let me erase this top part so I can do it in the same slide. So you might recall that adding, you just add each entry with its corresponding entry, so A11 minus A11, and you just keep doing. And of course, you know that 1 minus 1 is equal to 0, and actually any number n minus n is equal to 0. So anything, if you subtract itself to itself, you will get a 0. So in this case, we just get a matrix of zeros, which is the same thing as multiplying a times 0. I'm sorry, the other way around, just to keep it consistent. So 0 times a.